and then making sure the wire doesn't come out. Oh, like that. This is my Wago WM250V 3-phase infinitely variable lathe. Came with a 3-jaw chuck, 4-jaw and a faceplate, and I absolutely love it. But could it be improved? I was going to say that. Welcome back to the workshop. So this is episode 4 of the electronic lead screw installation. So this is the kit of parts that James Clough developed. I'll put a link to his excellent build series down below where he did all the R&D and all the development. Now, calling it a kit, yes, it is a kit in terms of all the hard work's been done, but you still got to do some adaptation to suit your particular lathe, because obviously James doesn't know what lathe you've got. So that's where the majority of the work lies, and customizing it and so on. As you can see, we've already made good progress. So I've got this opened out and got the display in here, and it's all built up behind. I've checked this out by hooking it up to the microprocessor, so we did that in the previous episode, so we know it all works. We know it also works when you hook it up to the encoder and the stepper motor turns as well. So just in case you're not familiar, on this type of lathe you have all these change gears, so these gears here, and they have to be configured, and there's some more in the box in the cupboard to set up to give you the particular ratio. So between the spindle and the lead screw, they're synchronized in a certain way so that you cut a certain pitch of thread. Basically that's what it is. But we're trying to make this a little bit more convenient, a bit more civilized, and the idea is to make the whole thing electronic. So it'll be a detector that detects the spindle speed, and depending on the setting you've got here for your thread pitch you want, or your feed per rev, it drives this at a particular RPM, so you cut a certain pitch or move at a certain rate. That's basically it. So I'm pleased to say we no longer need these, and we're going to replace it with this rotary encoder. So that's the model number there. It's the one that James recommends, so it's the one I've gone for. And please say the pulleys finally come in. Now this has got exactly the same number of teeth. I ordered one with the same number of teeth as this spur gear on here, and as I mentioned in the last video, this is based on an involute, and this is a T5 profile, but the T5 and the HTD profiles have both got involute type designs, or they're certainly very compatible for what we need to do, because we're only going to be but lightly driving this thing. So the new belts come in, which I think is going to be the right size. It's always with these projects you end up ordering a few belts because you never quite get it right first time, but I think that will go on there. This goes obviously onto there. It's all a bit tight in here. Yeah, and that looks like, and then I've got 2 of these little standoffs I've made, so they will go in there. There's one at the bottom, so as you can see there are slots in this so we can adjust the tension. So I think the first job is to get this mounted up in the right position, so it's not going to hit this but also not going to hit the front cover. So it looks like we're just going to make that. Right, let's get going. So while he's busy setting that up over there, I thought I'd take you through some of the electrical things as well. So it'd be good to make some progress on the enclosure and have a look at some of the electrics as well and see how far we can get with that in this episode. So on the right here we've got the electrical cabinet. I haven't opened that yet, but this is exactly the same model that I bought for the drill press project. Being a little bit lazy, I'd drawn a lot of this in CAD. I'd got a spare back plate that a friend of mine made for the other one. He had a spare one, and then I've been able to rough it out before it arrives, knowing that it's all going to fit. So you can see I've got this is an old power supply, but it's the same dimensions as the new one that's literally just arrived. That's the 48 volt one there that I'll use with that. You can see I've started to rough out where everything's going to go. We've got the microprocessor, the 5 volt supply, and some of the where all the terminal blocks are going to go. Got our mains terminals down there, bits and pieces, cooling fan. This will be, well, these are the GX16 that will go into the connector panel. I think I'm going to run that underneath. So this is the 48 volt supply that James used. This is a bit over spec really for what we need. I think this is the 8.3 amp model. You could get away with an awful lot less, but there wasn't much in it price wise, so I just went for this model. There's a few pounds, I think, something like that. And the reason James overspec'd his is because he was also driving a tool post grinder and he needed a bit extra current for that. So 5 amps I'm sure will be fine. Here's the integrated servo. Went for the same one that James eventually settled on. So it's the ISV 57T, so it's got the integrated drive on the back here, and as you can see there, you've got power, you've got your step and direction there, then alarm. There's no enable on this, but I don't think that's a big problem. And then when you're communicating with the RS232 port, so when you're flashing it and talking to it via the computer, there's a terminal there which you can plug into. and then you've got dip switches for hardware settings at the back there. So it's quite a nice, compact, neat little unit. And yeah, so one of the advantages of this that James pointed out, it runs to a pretty high RPM, so 3000 RPM, although the torque is only 0.6 Newton meters, which is quite low, whereas a sort of regular stepper that you might use on CNC machine might be 3 Newton meters. I know it drops off with RPM, and there'll be a critical speed as well, but this is 0.6, so why use it? Well, the fact it runs to 3000 RPM and that 0.6 is constant all the way up. It does not drop off. We've seen the data to prove that. So that means we can run it through a 3-to-1 reduction, so we come down to 1000 RPM, and now we're looking at 3 times the torque, and it's flat all the way across, it doesn't drop off. So this easily outperforms a regular 3 Newton meter stepper, and it has a nice smooth sound because it's a servo. Only kind of downside, I guess, if you like, is there's a little bit of tuning involved when it's on the lathe. It's got to work out all its parameters. But apart from that, and the price is pretty good as well. So and you've got the integrated driver. I just thought, yeah, let's give it a go. Yes, looked like a good solution. And speaking of pulleys, these are HTD5 pulleys. That's the tooth style and profile. This is a 24 tooth, and this is 76, so that's 3-to-1. Now this is a classic example of Excel engineering, typing the numbers in, working out your specs, pressing order, and they arrive, and I mean, this was about 30 quid for this pulley. I thought, wow, so the alarm bell should have gone off then, shouldn't they? That is a big chunk of aluminium, so that I might have overdone that. So in hindsight, maybe a 12 to a 36, I don't know if 12 might have been a little small, but you know, maybe could have done something better here. Never mind, this is what we've got. So if it fits, that's fine. The only worry here, there's a lot of mass and inertia there. So you want to remove mass from the outside to try and make that a little bit less hassle for the servo to monitor, you know, controlling speeds. I mean, we're not going forward and reverse rapidly, so maybe it's not a big deal. This comes as standard with a 12mm bore. The next one up was like 15, 16 or something. And it needs to be 14. So I've got to bore it out anyway. I've got to get it on the lathe, centralised, take that out. While I'm there, I could easily remove some of this material, or I could try and center it on the CNC machine and bore out some pockets. You know, basically take some material out is an option. Maybe we'll just see how we get on. But I certainly want to see if it kind of basically physically fits. Because, yeah, that's a bit bigger than I was expecting. But anyway, that's what we got. And then finally over here, this is the RS232 cable that came with it. So that's that one there. So that plugs into there, I guess that way around, yep. And then at the other end, you've got RS232 serial connector. I don't know if the PC in the workshop has got that on. I don't know if it's maybe a bit too new for that. So just in case it wasn't that expensive, I bought one of these, a USB to RS232 converter, which will go onto there. I've definitely got a USB port. I've got it on the front of the CNC panel. My only fear is, I always have a worry about converters and things. Some of these said they had a chip in, some not. I don't know if this is a direct wire, whether there's anything more clever going on, you know, to convert it from one to the other. I mean, that USB is a serial port, so I'm hoping it's just plug and play. We'll see. I guess there's people already who are into this stuff who know what I'm in for. But anyway, at the time of recording this video, I've got that. I haven't tried it. Hopefully it works. If it doesn't, I'll have to fix something out. I guess I could include getting a board in the back, a PCI board or something like that, that this serial port then plugs into direct, and you know, we got options, but one step at a time. So we've got those. I think we'll talk through everything else. Yeah, I've got a super long, yeah, it's worth mentioning that. I got a super long USB cable, I think about 5 meters, because my lathe's at that end of the workshop. It's like a car and a half garage length, and the CNC machine's at this end and the PC's over here. So I'll be running the tuning software on the PC, then I'll run this USB cable all the way down, and my plan is, on the console that goes into the enclosure, we'll have the female USB, and then that end, I think there's a USB-B or something, super tiny one, anyway, that one, and that goes into the microprocessor, which means without taking it out of the box, I can just plug in the USB at the front panel and flash new software. Yeah, if I get the steps wrong or whatever, something comes along in the future, firmware update, I don't know, whatever. I don't have to dismantle the unit and take the microprocessor out and unplug it all and unscrew it. I just plug into there on the front panel and I can talk to the microprocessor. That's the plan anyway. So you need 3 pairs of hands. Yeah, I think it's going to work okay. Now obviously on the spur gear there's no side flange to keep the belt on. If it comes too far this way, it'll quickly hit this piece, which is a bit higher, so that'll keep it on. That side, in theory, it could come off, but on this side you've got flanges both sides. Because it's so short, I think it's very unlikely to wander, certainly not that far across. Probably won't even make it with the tension on it. In fact, that's probably a bit too tight anyway. It's only driving an encoder, so right, looks good. So we're clear here. Now, I've never used this low gear, this low range, with the inverter on it. I've never really had the need to. But in theory, I guess, or can I? If I ever wanted to use that, could I still get the belt in? Yeah, once it's in, I think it will clear. Can I do that another way? No. Or maybe like that. Oh yeah, yeah. Oh, that easily clears. Probably got 8mm clearance, so that's fine. I rarely use that. Well, so I've never used that, so that's all right. And then on the front here, on the cover that goes across, it's got about 8 to 10mm return flange on it to give it some stiffness at the edge. So I need to get clearance for that to come around here. It may just catch there, but if it does, I think I can sort of come around that, then go in and then put it on. Once this is all buttoned up, you know, for good, don't really see the need to take the end cover off, but worst comes to worst, I can just put a little radius on the end of there, and that'll do that one. And then the cable, because I didn't want it getting caught in here or in here, I knew it was going to be quite close. That should go through there. Should be a little snap fit in there, yeah. And then I was going to cable tie it onto there, and then it will go off round to the control box. So as long as you tie that in enough places, that should also be fine. Right. Okay, looking good. Well, while we're over here looking at the electronics on this side, I'll just thought I'd show you the this integrated servo. So a couple of options that I talked about in the last video. Now I've got it in my hand. Yeah, I didn't think they were going to work, and I'm not really happy with them. So one option was to go down there. I'll take these knobs off. Might just about fit, but then you're going to have the cables coming out the top, so not really any good. You could do it that way, but then you're going to have the cables coming out here. It doesn't really feel very good. You're going to get a lot of the swarf on there. You're going to have to build a shield. Yeah, not so much. Yeah. The other option, it's a similar story here. It sticks out a long way. You have to build it all in. You can't see these. Maybe not the end of the world. You could get to them. You could go that way. Yeah, somewhere there. But then you've got the cables coming out. It's going to look a mess. You're going to be in the way of yourself all the time. So I think anything on the front here long term isn't really going to work. I did think about it, but I did forget to mention it in the last video, so thank you to the comment who mentioned this. Of course, this lead screw could be driven from either end, and I have seen in the distant past CNC machines where they've driven the lead screw from the other end. So let's just take you over there and show you what that might look like. So the lead screw runs through here, and it's got these kind of jam nuts on it there, so you'd have to arrange something to come off there. I mean, not the end of the world, but there's not an awful lot there. Then in terms of where this would go, you've sort of got that, which doesn't really work. You've got that, that's an option. I'd have to check that the saddle didn't come back that far. I don't think it does. Could work. Again, you've got the electrics down here, and you've got a very long cable to run all the signal and power through, which I didn't really favour. You're going to get limited pulley ratios on here, size-wise. You can't really tuck it around the corner. And then obviously if it's sticking out like that, it's right in the way of something else. So yeah, I think for small little 3Nm steppers buried in here or tucked down here somehow for CNC, maybe that'd work, but I think this maybe is a little bit too big for that. So let's go and have a look back at the front end again. So this is the end of the lead screw that we've got to drive. So let's have the large pulley on, then we'll have a small pulley on our little servo here. And I did look at that little hole. So if I trimmed that bolt back, which is the bit that holds it to the main bed, width-wise it would fit. Height-wise it wouldn't, but if I cleared that back it might just about, but then I've still got the cables coming out the top, so you're really going to struggle there. The other thing you won't be able to see there, down there it's exposed to the chip tray, and then there's a sort of passageway through here as well where the chips that come out of the general lathe machining area can come straight through. Maybe I could cover that one off and seal that, but the bottom one, a bit difficult. You're always going to have this exposed to chips, maybe coolant and so on, which didn't feel like a good idea, and you have to go put an enclosure. Yeah, didn't really like the sound of that, so it has to go a long way in as well. The other option I looked at was having it way back here, but I couldn't really find, as you can see, the inverter is in the way on mine, so I can't put it where James put it. I've got the inverter and the fan there. He had a separate inverter on the wall, but this came with it fully fitted. So we're back to one of my viewers' suggestions, so thank you Tony for this one, which I think makes some sense. You know, you just got to bite the bullet and go with it. This is the logical one. Have it on the front here somewhere. You've got plenty of room to have your 3-to-1. You've got plenty of room to make up bracketry and so on. You can still not interfering with the drive belt. The only thing is, so that nut there, that face represents the back, so when the cover comes on it goes up to there, and then there's those thumb nuts that go on the back, so that's essentially where the cover will be. And clearly once you've got that in a sort of logical position somewhere like that, let's say, the cover's going to come to here, so you'll definitely need to relieve this, but to be able to get the cover off you'd have to relieve this area. So I think you're going to end up with quite a big hole, and I think what I'd then do is kind of style it in so that the cover has a big hole and it's got like maybe a chamfer like that, and sort of that way, so it's quite a big open area that then gets covered off, so plenty of clearance. And then there's enough room for the cables to come out, because they got to come out and not get tangled in the mechanism and find their way back to the controller. But in terms of location, it's there. I think maybe arguably they'd be better on their side, but you know, somewhere there, that's where it's going to go. As you can see now, I'm working on the control panel that goes inside the enclosure. I've got it all roughed out and I've drilled the little holes. These are little self-tapping screws, sort of look like this, that cut their own thread. And then we've got the power supply mounted. I was going to make a complicated bracket so you could screw it from this side and remove it, but you know, how often am I going to need to remove it? And if I do need to do that, I can just undo the nuts, take the panel out, because what I've actually ended up doing is just putting the screws through. Well, that one was actually I had to use, it's like a wood screw type of screw, because that's actually one of the enclosure types like that. For some reason they give you 4 tapped holes here for M5, but on this side they only give you 2, so I've used one of those. I don't think it's going to go anywhere. So that's what we've got on the power supply side, and then we've got the DIN rails and some of the cable trunking as well down there. And then on this side, this is where the microprocessor will go, and I ended up making these little aluminium blocks here, little spacer blocks, and then they're just screwed in from the back through there, and there's 4 places. And then I've recessed them and then put a little chamfer on there, because when the board sits on I didn't want it shorting out. Now this has all been sprayed. I sprayed it with a sort of metallic lacquer just to stop it rusting over the years, but I think even so it's going to come nowhere near any of the contacts. I did have some little spacers somewhere, but I can't find them, plus I don't think they're long enough to space the board off, because the board's got these plastic connectors that go down as well, so you need to bring it away. So I think that's going to work. That's going to look like this. I'll just show you. So there's those little pieces that stick down, which I think allow you to connect these little daughter boards or booster boards or whatever on the back as well. And then that ends up going on there, and then there's just the 4 screws just to screw that in place. So I think that's going to work quite well. And then you can see on the underside, yeah, these are little pins that stick through, so I wanted to make sure I was well clear of those and didn't short anything out. And there's the USB one that side as well. Right, so I think we're all set. We've got the crimp terminals over here for some of the crimp ones. We've got the ferrules as well, so we can make up all the cables. think let's get going. So where to start? I think we'll start with getting the power to this, so we'll get the little terminals on for that. So I've got some these little DIN rail earth terminals, so these you can see are a little bit different because the metal goes all the way back to here. That earths it onto the DIN rail, and then it earths through the screws and into the main container, and everything's earthed from that. And then if you compare that to the regular ones, this would be for neutral. You can see it doesn't go down there, it's just got the plastic at the bottom, so it's just a join straight through. Right, let's get those installed. I wonder if we start at this end, I'll start at the neutral end to make sure I've got space. If we just see, where's that going to end up? And these are my lives. I need enough for the 48 volts to get through into there. It's going to have to get through that gap, so yeah, that looks okay. Alright. Let's get those properly installed. Okay, ideally I should blank that off. There's like a blanking plate, but I don't have one that matches this, so we'll just use this that also came with this little set here, which is just a end of row terminator. So it's got little claws that grip onto the DIN rail. It's just a mechanical end stop really. Alright. I think now all we need to do is just get everything wired up. So we'll get all these, start with a live. Okay, so we've got our wire strip back. You need a reasonable length because ideally you need to go most of the way towards the end of that little tube. And then make sure there's nothing exposed here, and then that this outer sheath is definitely inside there. Like that, and you can see hopefully it's about to there, and we'll just crimp that on. I do like these, they're really clever, so when you squeeze it, come in from all sides like a camera iris. Quick pull to make sure it's definitely on. There we go. I'm using ring terminals on these. I do have some fork ones as well. Yeah, this sort of style, but prefer not to use those. You know, in theory they could come out, couldn't they? So the ring one's a better option. That's our neutral, 4 Newton meters. Click. I tend to get it so the wire's just sticking out, and then put it in so that the colours on there, the wire comes in from the colour side, because you can see the profile is different on each end. And then making sure the wire doesn't come out. Oh, like that. I think that one's junk. Ugh. Try that again. Oh, okay. Got it this time. Okay, I think that looks really good. So I've put them on the right side there, because we'll have power coming in on the first one, and then power going back out again, sort of daisy chaining out to the digital readout. So when you turn this device on, it will run this and the digital readout in one unit. And then we've also got the outlets on the top, and they'll go up to this unit here, which is our 5-volt power supply. I decided to go for this one, that's 3 amps, that should be plenty. So 15 watts, so that will power the microprocessor and the fan. Little cabinet fan. I think it will go at the top, but I haven't fully decided. But this is a special, it's a 5-volt one. There we go, yeah. 5-volt fan, so it saves me having yet another power supply, you know, for a 12-volt or something like that in the cabinet. So this mounts on the DIN rail in the same way. So pull this back, put it on the DIN rail, and then click it to location. When you want to get it off again, you just lever that little thing like that. And then what I like to do with these before they go in, or any type device really, is they often come with the little shutters wound fully tight, which makes sense, they don't wrap around or the screws fall out. And then it's usually best to open them up before you install it. Usually a bit easier in your hand, like so. Okay. Now this one's got your live, neutral and earth in as a normal one. You got your plus and minus 5 volts out. It's also got this one here called DC OK. Now I assume that's to run to some kind of monitor that makes sure this is running okay and shuts the system down if it's not. I've not seen that before on these devices, so interesting. I'll have a look into that, but I'm not going to use that at the moment. I'll just use the 5 volts plus and minus. Right, so let's clip that in place. Okay, and basically we'll wire that up in exactly the same way. Okay, so we've got all those wired in now. Of course these are all single at the moment, they're not joined together, so the power's not going to flow between these, so you need to use these little jumpers. Now these terminal blocks are made by Dinkle. I'll put a link in the description below. If you use a different brand, then each one needs its own set of jumpers. So these are the ones that came with this one. They come in 2, 3 and various number of pins. 2 is nice and easy because you've got double row there, so you can always make it work. So that joins those two together. And then that one, make sure all 3 are joined together. So these are the 2.4. I've also got some 4mm spacing ones for the larger blocks. Again, they're Dinkle, and these I think I've got some 2s and 3s. Yeah, you see some 3s in there. So obviously these are the 2.5. So we'll join the neutrals as well. Now if you need to get them out, they've got a little a little recess in the side there. So it's a bit fiddly, but you can sort of lift them out, leave them out like that. Alright, so I've got my neutrals all joined here, sorry, and my lives joined. There. So we haven't got the lines coming in yet, or the ones to the DRO, but we'll do that right at the end. Right, I think next we'll have a look at the 5-volt supply and the bits that need to go up here. Now the power that comes in, that runs the 5-volt and the 48-volt supply, that will run off a normal mains cable, and that will have its own, probably a 5-amp fuse I think I'll put in there. So that protects this incoming side of the wiring. In terms of the wiring that comes out of here, so the one out of the 5-volt unit, I'm going to use this little fuse holder here. I think 5 amps will be enough. I could probably even drop down to 2 amps or 3 maybe. I haven't got any 3 at the moment, so we'll just get it going with this. And again, this is DIN rail mounted, and the idea is so which way around is probably going to be logical that way, I think. Yeah, because that'll be the top. So we'll drop the fuse in there, and then it will just clip in, and that makes the connection. So I'll have that live. I'll label this up so we know that's the 5-volt fuse, and then as before, that just clips onto there. Right, so I'm going to use a couple of terminal blocks now, and we'll wire it up so we can take our 5. We need to be able to supply 5 volts to the microprocessor and to the fan, so we need plus and minus outlets down here. Right, let's get on with that. Okay, so we've made some progress. So all the mains wires are connected. So we've got the power supply for the 48 volts and the 5 volts. They're all plugged in. And then on the 48 volt side, we've got those running through there. This is the fused outlet, so that'll probably be a 5 amp fuse in there for the positive out to the stepper motor, or the servo, and then our negative there. And then for the 5 volts, we've got that going into 2 of these terminals. So one of them will be for the fan, which is up here, the internal cooling fan, and then the other one, which I think we'll put on next, is for the microprocessor, because that needs 5 volts as well. So yeah, let's put that on next, get the 5 volts wired into there, and then I think we can put some mains in here and just check it's all going to work. So the microprocessor goes back here. As I showed before, it goes onto these little aluminium stands I made. They're screwed from the back, and they've got a bit of a recess there, just to make sure they don't short out any of the pins. And then they're raised up, so it just gives clearance for these where you can bolt on or connect additional headers and daughter boards and so on. Get that on there. And then just got 4 little screws. And then we've got to put 5 volts in here, so that will come out of one of these pair through there to there. We also need the encoder, so that will go onto these pins here, and the cable will come through here down and into the front panel, where there'll be a GX16 connector for that. And then we've got the servo, which will connect onto here, and the wires will go through into here and again out to a GX16 connector. Oh yeah, there's one more, which is this little micro USB. This is for flashing the software. So that will be this little connector. So that will connect. Oh, I might have to go underneath those power cables. We'll have a look at that in a minute. That will go into there. And then the other end will go on to the panel on the bottom of the enclosure. So from the outside it will look like that, and we can plug our USB in there and flash software on it and make changes without having to take the board out or trying to fiddle in here and try and get a connector in there. Right, let's get all that wired up then. Let's make sure I've got enough room to put the header on there. Okay, I've just connected up a mains plug here, so that goes into the live, neutral and earth. I've triple checked. We're going into the 48 volt power supply and the 5 volt power supply. I haven't got this plugged in yet, so what we'll do, we'll turn this on, and then we'll just get the multimeter, make sure we've got 5 volts coming out of there, we've got 48 coming out of there. So yeah, that should be it. Right. Switch on. Okay, final check. Okay, 3, 2, 1. Okay, the 2 green lights have come on. Okay, so we should have 48 across here. Yeah, looks good. And we should have 5 volts across here, and it's center positive. A bit fiddly. Yep, that's positive. Alright, so in theory, when I plug this in, it should come on. So the lights come on there, and on the little daughter board, we've got power on the 5 volts, power on the 48, and you may just be able to hear the fan. Okay, I think that's probably going to be about the end of this video. I'm really pleased with progress there. So I've made my control panel, and it looks like in principle it's going to work. A couple of things I'm not super happy with. So I did order a straight connector. It was certainly straight in the picture from a little 2.1 5.5mm jack there, and it's 90 degrees, and it's probably going to clash with the servo plug that plugs into there. So I've ordered a pigtail with a straight connector. So yeah, I'll sort that out and then connect that into the 5 volt supply there, and it'll come straight out, so that should be a bit better. I think that's yeah, and then the other thing was these were getting a little bit close, so I ended up moving these across. But yeah, I think that's going to fit, and that's okay. So great progress so far, pleased with that. It is actually working. So I think next time we need to have a look at the enclosure, which is here. Let's put that down without hitting anything. So it's exactly the same model that I ordered last time from a drill press project, but weirdly, it's although it's the same model, same supplier, same everything, it's got slightly different knockout internals. Let's just move these out of the way. So in terms of the cabinet inside, yeah, I don't know if you can see there, so it's already got a little knockout in the bottom, and the last one that arrived, exactly the same as this, same everything. This was solid, so the panel I designed, the knockout, my extra panel I'm going to custom machine, was a lot bigger than that, and it was over here. So I've ordered a really big piece, really big panel, so I'll cut out the bit I need in my original plan, and then just put the big panel over the whole lot, and won't use that, it's far too small anyway. Apart from that, I think the enclosure is going to work okay. So obviously this is the main back panel that goes inside there. So you can see it's got this kind of neoprene rubber, whatever it is, on the door there to create the seal when you shut it. So it should be airtight. So in which case I'll probably put the fan on the top and have negative pressure in here, and then I'll have a filter on the bottom as part of the custom sort of panel I'm going to put on the bottom there. Yeah, so I think I'll put that there. So it's not really going to get chips in it, it's round the corner from the lathe, so I think that will be okay. And there's nothing else really to go on this. The door will be as it is, it's just that custom panel. So once I put this main electronic panel in the back there, I've got to obviously make all the little tails up that go from the back of those GX16 connectors and the mains IEC connectors between there and here, and then I've got to make up all the leads that go from the plugs there out to the various ancillaries like the encoder, stepper, and then make sure I wire it through the lathe so it doesn't get all tangled in any of the machinery. So there's still lots of little jobs to be done, but it's making good progress. Okay, so I think that's it for this video. If you enjoyed it, give me a thumbs up, leave me a comment. If you want to see more of these, feel free to subscribe, click the bell icon, then you get notification. And I think all remains to be said is thank you very much for watching, and see you next time.